Hi everyone, this is Hor Wai Keat from UNITEN with student ID of EEEB1034, and today I'm going to show you how I solve my digital logic design final class project with subject code of EEEB1034. As you can see, here is the question: design a counter that counts on the sequence and reverse sequence of your student ID using two different types of flip-flops. So my student ID is 0, 1, 0, 7, 6, 8, 4. So we are gonna count based on this sequence 0, 1, 0, 7, 6, 8, 4. And the first step is going to be decide the number of flip-flops. So in this question, we are going to use 5 flip-flops. And the type of flip-flop, the first type of flip-flop is going to be J, K. Depends on your preference. You can choose either T, SR, or other flip-flops. And the second step is going to be excitation table. So as you can see, here is the excitation table of JK flip-flop. So Qn represents the current state, and Qn plus 1 represents the next state, or the future state. And the third step is going to be state diagram. So state diagram, since we are using 5 bits, then I'll just write in 5 bits. So here 0, here's 0, 1, 0, 7, 6, 8, 4. And the sequence is going to be like this. As you can see, here the counter flows in ascending order of my student ID 01076884. So the counter can count in reverse sequence as well. So in this question, we are going to use a switch to control it. With the switch is in 0, then the counter will count in ascending sequence. If the switch is in 1, then the counter will count in reverse direction. So with the state diagram, we can construct the circuit excitation table. So in order to save time, I have did it before the video starts. So here, as you can see, the switch controls. Here is the up counter or the ascending counter, and here is the down counter or reverse counter, and the switch is being used to control this part. Up switch is 0, and if the switch is 1 activated, then it will count in reverse direction. So I'll just show you on Q5 0 0, compare it using this table 0 0 0x, 0 don't care, and 0 1 1 don't care, and 1 0 don't care 1, then 0 or 0, then it should be same, 0 don't care, and 0 until here 0 0, then 0 don't care, and 0 1 1 don't care, 1 don't care, then 1 0 1 0 don't care 1, and 0 0 0 don't care. So others are the same as well. You just need to compare it one by one. We are going to determine which flip-flop is our MSB and which one is our LSB. So you can see here is our MSB, but then we are not using it because here we only need 4 pins. So we only put 4 LEDs in these 4 pins. So here should be our MSB. And Q1 is our LSB. So in order to save time, I've already moved all the values from the excitation table into this table to proceed to the simplification of K-map. So right now this represents J5, K5, J4 and K4. So J5, the first group, is going to be this, and second group is going to be this. So this J5 equals S bar Q3 bar Q1 plus S Q3 Q1, and K5 is going to be 1 J4. So J4 is S bar Q3 Q2 Q1 bar plus S Q3 Q2 bar, and K4 is going to be 1, since all of these are just don't care and 1, so is considered as 1. Move on to J3, K3, J2 and K2. So J3, the first group is going to be here. Second group is going to be it here. Third group, and the fourth group. So J3 equals S bar Q4 plus S bar Q5 plus S Q4 plus S Q5 bar Q1 bar and K3. S bar Q3 Q2 Q1 bar plus Q3 Q2 bar plus S Q3 Q1. So J2 is going to be this. S bar Q5 plus S Q4 K2. K2 is S bar Q1 bar plus S Q3 Q1. So right now let's move on to J1 and K1. So J1 and Q5 plus S Q5 plus S Q3 Q2 and K1. K1 is going to be 1 because all of these are just 1 and also don't care. And with all the simplification, then we can conclude it using this that I've done earlier. And with this, we are able to construct the circuit design. So right now, as you can see, here is the circuit after the K-map simplification. So if I turn on this, then it will flow in ascending order. By the way, this is the enable pin, because if I put it in 0, it won't work. and the switch in 0. So if the switch is in 1 or switch is on, then it will flow in reverse order. I'll leave the link at the description box below, so feel free to check it out. Let's move on to the next type of flip-flop. So the steps are going to be the same as well. Step 1, decide number of flip-flops is going to be 5 as well, but this time we are going to use T flip-flop. And the second step is going to be excitation table. So here is the excitation table of T flip-flop that I've prepared earlier. Qn represents the current state, and Qn plus 1 represents the next state. And T is the T flip-flop state. And the third step is going to be state diagram and circuit excitation table. So here is the state diagram that I've showed you earlier in the JK flip-flop. Is going to be the same as well. So the counter flows from 0 to 1, and then 1 to 0, 0 to 7, 7 to 6, 6 to 8, and 8 to 4, and in reverse sequence as well. It's going to require a switch to operate, whether it's in reverse sequence or in ascending sequence. So right now, here is the circuit excitation table that I've prepared earlier. So you just need to compare 0, 0, 0, 0, 0, and 0, 1, 1, 0, 1, 1, 1, 0, 1, 1, 0, 1, and zeros, zeros, and zeros, zeros, 0, 1, 1, 0, 1, 1, 1, 0, 1, 0, 1, and 0, 0, 0, 0. You can do it for others as well. In order to save time, I've already prepared this table, so you can prepare yours as well. As you can see, here are the tables for T5, T4, T3, and T2 in order for us to do the simplification using K-map method. So here, T5, the first group is going to be at here, and the second group, third group, fourth group. So here is going to be S bar Q5 plus S bar Q3 bar Q1 plus S Q5 plus S Q3 Q1. Here T4 first group is going to be at here, second group, third group, fourth group, S bar Q4 plus S bar Q3 Q2 Q1 bar plus S Q3 Q2 bar plus S Q4. So here T3 S bar Q4 plus S bar Q3 Q2 Q1 bar plus Q3 Q2 bar plus S Q4 plus S Q5 bar Q3 bar Q2 bar and Q1 bar. 1 2 3 4 5 6 7 1 2 3 4 5. So for T3 it's going to be S bar Q4 plus S bar Q5 plus S Q4 plus S bar Q3 Q2 Q1 bar plus Q3 Q2 bar plus S Q3 Q1 plus S Q5 bar Q3 bar Q2 bar and Q1 bar. For T2 T2 is going to be S bar Q5 plus S Q4 plus S bar Q3 Q2 and Q1 bar plus S Q3 Q1. Now here is the table for K-map simplification of T1. Oops. S bar Q5 bar Q4 bar Q3 bar plus S bar Q5 plus SQ5, then plus Q3 bar Q1 plus Q3 Q1 plus S Q3 Q2. So with the expression, we can conclude using this, and with this, we can build our circuit. So as you can see, here's design for my ID number, the counter, using my ID number. So if the switch is in 0, then the counter will count in ascending sequence. And if the switch is in 1 on mode, then the counter will count in reverse sequence. That's one thing I forgot to mention in the earlier design, which is the labeling. So this is Q1, Q2, Q3, Q4, and Q5. And Q1 represents the LSB, and Q4 represents MSB. Here, this LED is connected to Q4, Q3, Q2, and Q1. So the Q1 is at the last one, since it's LSB, and Q4 is the first one, MSB. Same for the earlier design, JK flip-flops. Using JK flip-flops, Q1, Q2, Q3, Q4, and Q5. We didn't put LED on Q5 because Q5 we don't need the values of it. We only need it to generate the zero, the second zero in my ID number, 0, 1, 0, the 0. So same, this connects it to Q4, Q3, Q2, and Q1 respectively. And that's all from me. I hope you enjoy this video. That's all from me, and I hope you're enjoying this video, and I hope this video also helps you to solve this kind of problem. So be sure to check out all the links that I've posted in the description below. Thank you, and have a nice day.